Hello, welcome to this video. This is lesson 2 of unit 1C, and we're going to talk about long division and, more importantly, the implications of long division, because you should be familiar with long division. So you'll be successful if you can divide two polynomials, if you can factor quadratic polynomials, and really you can understand when one polynomial is a factor of another polynomial. So let's go ahead and jump into this idea, which is important. It's called the factor theorem. And what the factor theorem says, a polynomial q of x is a factor of polynomial p of x if and only if the remainder is 0 when p of x is divided by q of x. So you can go ahead and imagine you are given two functions here, p of x and d of x. If you divide these and you get a remainder of 0, then d of x is a factor of p of x. It's a part of it, okay? And so like imagine a trinomial here, and if you broke down that trinomial, it'd be divided by one of its factors. Well, if you divided those, you would get a remainder of 0, okay? Now, furthermore, I can go ahead and I can take this and I can multiply times the quotient, and that will give me back p of x, okay? And so I'll kind of put this in plain terms here. If I had x squared minus 4 and I was dividing by x minus 2, right? If I factored that numerator, this would give me x plus 2, right? With a remainder of 0, okay? And you can think about this, if you factor these, you could cancel, right? You would just have x plus 2 left over. Well, so if I divided x minus 2 into this, I would get a remainder of 0, so therefore x minus 2 is a factor of this. And furthermore, if this gives me x plus 2, I can go ahead and multiply these, and it would give me back our numerator, the x squared minus 4. Okay? So let's go ahead and recap a couple of things, because this really has to do with rational functions. One, rational function has a slant asymptote with the equation y equals mx plus b when the degree of the numerator is exactly 1 more than the degree of the denominator. Also, a whole if the multiplicity of a factor in the numerator is equal to or greater than the multiplicity of the same factor in the denominator. So if I divide, right, and I get a remainder of 0, it is a factor. That means that I have that factor in the numerator. So if you divide and you get a remainder of 0, guess what? You have a whole. If you get a remainder that is not 0, then guess what? It's not a factor. And then that would also mean that you have a vertical asymptote. And vertical asymptote, if the multiplicity of the factor in the denominator is greater than the multiplicity of the same factor in the denominator, or is a unique factor in the denominator. So let's go ahead and let's look at our first example here. The rational function r is given, where r of x is p over q, where p of x and q of x are given. Which of the following statements is true about the graph of r in the xy plane? So let's go ahead and first of all, let's write this out. So r of x is equal to p, which is x cubed minus 2x squared plus 3, divided by q of x, which is just x minus 1. Okay, so they say which is true, and when you look at this, you might look at your answers. They say when it's divided, you have a vertical asymptote, you have a whole. I mean, I don't know. Well, the clue is divided. I'm going to have to go ahead and I'm going to have to use long division. That's what this lesson's about. So let's divide x minus 1 into x cubed minus 2x squared plus 0 plus 3. Again, I left that 0 because I'm missing linear terms, x to the power of 1. So let's do some long division. I have x cubed divided by x gives me x squared. So I get x squared, and when I multiply, I get x cubed minus x squared. We can change our signs, right? And so what I'm doing is I'm dividing my first terms, x cubed divided by x. I get x squared. Then I'll go ahead and distribute, right? I take this quotient, x squared, and I multiply times my divisor, the x minus 1, we get x cubed minus x squared. So hopefully this is not your first time being exposed to long division. If not, I have lots of other videos on long division. You can go ahead and look at them, search my page for them, where I'll go over it in slower detail. But again, that's pretty much it. Step 1, divide. Step 2, multiply, distribute. Step 3, subtract. Okay, and then we'll go ahead and these cancel. We get a negative x squared, and then I'm going to bring down, right? That's your next step, bring down. Okay, and then we just repeat. So now I'll go ahead and divide negative x squared by x, which gives me negative x. so minus x. I'll distribute this negative x times the divisor, x minus 1, and we get negative x squared plus x. Change my signs, positive, now a negative, I get a negative x, and I'm going to go ahead and I'm going to bring down the 3, plus 3. Okay, one more time, we have negative x divided by the leading term of our divisor, x, which gives me negative 1. So minus 1. We'll distribute, I get negative x plus 1, and that doesn't look like it's going to cancel out. Plus minus, I get a remainder of 2. So, the remainder when p is divided by q is 0. That's false. So it's not a or b. A non-zero constant. Yes, that's what 2 is. The remainder is a non-zero constant. And if I have a remainder, this divisor, x minus 1, is not a factor of this. So it's not going to be a whole. It's not going to be a whole. So D goes out the window. The answer here is C. Essentially, you can quote or correlate a remainder of 0 is going to provide a whole. A non-zero constant is going to be a vertical asymptote. There you go. Let's look at the next example. Example, the functions d and h are given. Which of the following is true about the remainder when h of x is divided by d of x? So notice they say here, oh, it has a slant asymptote. It does not have a slant asymptote. The remainder is 0. The remainder is x plus 2. What's it going to be? So first of all, let's identify the initial setup. They say, what is the remainder when h is divided by d? So I have to set this up correctly. H of x divided by d of x. H of x is 4x to the 4th minus 19x to the power of 3 plus 10x plus 2 divided by 4x squared minus 3x. And so looking at this, well, I guess we'll see what, well, I mean, look at the powers. It's not one more, so I don't think it's going to have a slant asymptote, right? It's only if it has power of one more, it'll be a slant. So I do not think it's going to have, does not have a slant asymptote. Does not have a slant asymptote. So I think it's between A and, or sorry, I don't know why I'm crossing that out. It does not have a slant asymptote. I'm going to cross out A and C. So it's between B and D. So let's go ahead, let's do this division. Let's see what we get. So we get 4x squared minus 3x divided into 4x to the 4th minus 19x cubed. Oh my gosh, you guys, this is a big one. This is a big one. So let's go ahead and divide. So 4x to the 4th divided by 4x squared gives us x squared. So we get x squared. We'll distribute, and we get 4x to the 4th minus 3x to the 3rd. And we'll change our signs to give us a negative 16x cubed plus 0. And then we're going to go ahead and repeat. So we get negative 16x cubed divided by 4x squared gives us negative 4x. Okay, we'll go ahead and distribute. So negative 4x times 4x squared gives us negative 4x cubed, like it should, plus 12x squared. Okay, change signs, plus negative 12x squared. Now I have a plus 10x. And we should have a negative on that 12x squared. Okay, so now we're going to go ahead and we'll do this again. So I take my first term, negative 12x squared, divided by my leading term, which is 4x squared, and we get negative 3. So we get a negative 3. And then we're going to go ahead and distribute. So now I get a negative 12x squared and a positive 9x, and then we'll go ahead and change our signs. So positive, those cancel, and a negative, and I get a remainder of, looks like, x. And then I'm going to bring down the 2. All right, so there's my quotient, x squared minus 4x minus 3, and look what the remainder is, x plus 2. It's not 0. So what is our answer? It is not going to be B. Answer is D. Okay? Does not have a slant asymptote, again, because that only occurs if your degree is one more. All right? Okay. Here, this question is labeled as a practice, and I'll let you get the practice doing the long division. I'll have you do that, but I want to talk about the implications in this question here. They say the polynomial function f of x has a factor x squared plus 4. Which of the following is true about the zeros of f of x? So whenever they say this polynomial has a factor x squared plus 4. What they're telling you is that when you divide that, you're going to get a remainder of 0. Okay? So what they're saying is that I can divide x to the 4th minus 2x cubed plus x squared minus 8x minus 12. I can divide this by x squared plus 4. Okay? So, and what you might want to do when you set this up is leave yourself a 0 there, because you're missing your linear term. And so here's what I want you to do. I want you to go ahead. That's what you should have gleaned from that, is when I divide this, I'm going to get a remainder of 0. So they're telling you long division is possible. I want you to go ahead and pause me. I want you to do the long division, and then I'll talk about the conclusion based upon what they're saying here, okay? So pause me, long divide. All right, hopefully you went ahead and did long division, and what you should have got as a quotient is x squared minus 2x minus 3. Okay, and so again, the math for each level is kind of here. You can pause me and double check against your work. Check for, changing the signs, and did you when you brought down, did you bring the sign down correctly? I want to talk about the implications. So what this is saying, remainder of 0, is that this times this is going to be f. That these are the factors of f. So f of x is equal to x squared plus 4. X squared minus 2x minus 3. That's essentially another application of this factor theorem, right? Remainder of 0. After I do the long division, these are the factors. So this is important because they're asking about the zeros. What are the zeros? Well, I want to set this equal to 0, and I got to find the zeros. Okay? So I want you to go ahead, see if you can identify the answer A, B, C, or D. Pause me here. What do you think it is? I'll talk about the solution. Okay, hopefully you went ahead and factored your first binomial there. That's sum of squares. You cannot factor that. Your second binomial here looks like we have x minus 3, x plus 1. And so we're going to get 3, and we're going to get negative 1 as zeros. And that x squared plus 4 here, this is going to give us x equals plus or minus 2i. Okay, when I set this equal to 0, I move that 4 over, it's a negative 4. And so when you take the square root, it's imaginary. So answer here is 2 distinct real zeros. These are different. If they were the same, it would only be 1 distinct real 0. But they're different. So 2 distinct and 2 non-real zeros. Answer A. All right, hopefully you learned about some of the applications of long division, especially when determining zeros of a polynomial function, determining if you have a slant asymptote, and determining if you have a whole or a vertical asymptote. Give me a thumbs up if you learned something in this video. Catch you in the next one.